Good afternoon. We are going to the next talk, which is going to be the workshop on exploring the LLM frontier. And my name is Carlos Lizárraga. And today we're going to be talking about Langchain, which is a framework for working with LLMs. Let's see, let me. Okay. Everyone can hear me well? Yes? Okay.
Yes.
Okay, thank you. So let me jump into today's talk. So let me go back. Well, let me jump into the Data Lab homepage. Remember that this is the link for the Data Lab GitHub page where you can find all the learning resources. And down here, you will find this workshop, Exploring the LLM Frontier. And today we will be talking about Introduction to Langchain. This is the schedule of the program. Let's see. No, well, it's not this page. Sorry. So today we'll be talking about the Introduction to Langchain. Okay. So we have been talking for the past few weeks. We're trying to work with different LLMs. Last week, we showed how to use the Ollama program. The Ollama allows us to run LLMs locally in our machines, and also Ollama offers you a wide variety of models that you can run. And today, so we have to introduce a different tool, which is called Langchain, and there's a presentation here. I'm going to jump into this presentation. So open. And let me start this presentation. So I'm going to be very brief, and then after this presentation, then Enrique Noriega will jump in and present you an example, a Jupyter notebook that uses Langchain to do several tasks related with LLMs. Okay, so what is Langchain? Langchain, it's a library written in Python, but also you can find it in JavaScript. And also this library can help you work with different types of data, which are hosted somewhere else. Can be proprietary, can be, for example, or can be public, like YouTube videos, archive documents, Twitter handles, Wikipedia, and also any type of documentation like PDF, text, JSON, markdowns. Also, there are going to be different data stores, and this information of this data can be unstructured or structured. So when we are trying to develop a new application using this type of data and be relying on the use of some LLM to develop some tasks, then Langchain will be a tool to consider. Okay, so all right. Next. So how does Langchain work? So in Langchain, you will find two concepts, chains and links. So chains will be the sequences of actions. So you have here chains, and these actions can, for example, you want to summarize some article, you want to ask questions to a specific document, or you want to custom a specific chatbot for some company, or try to interact with some custom APIs from some other company that has some information. And this will be the links. So at some point you are retrieving information, you are working with the large language models, you are going to be storing information in some way. And also you can create different templates to interact with the large language models, or you can design some software agent that can do some specific tasks that you design. Okay. And what are the components of a Langchain? So the components will be an interface with the large language models, and also you will have a series of templates, prompt templates. Also, you can have different agents that do specific actions, and also be handling memory and memory retrieval using some tracking events. Okay, Langchain will simplify some of the tasks we want to do. For example, if we want to write a chatbot, or we want to design an agent, or be working with different applications, or we can just try to develop some code and try to understand. We can do queries for data. We can evaluate different tasks or documents. We can extract information. We can have a series of questions and answers using about some specific document, or we can do, for example, summarization of a text. These are common tasks that we want to do, and Langchain will help us develop more efficiently an application. Some advantages and disadvantages of Langchain. Well, Langchain in particular will accelerate our development. It's scalable and flexible, can improve our productivity, and can enhance the user experience, and also be future-proof of investments. The disadvantages will be it requires some learning curve, and also it will depend which large language model we are using. But it's efficient, versatile, and there is a large community support, and it's modular. There are some other alternatives to Langchain, but Langchain will be part of some framework that you can be interacting with other applications like Flowwise, Langflow, Langsmith, or for example, if you're using Llama Index, you can use Langchain to be interacting with the large language model, and use the other applications to be interacting with the information and the user. Okay. So very briefly, that's Langchain. And going back to, let's see, stop share. And next, Enrique can continue. The notebook will be in the bullet number 7 in our notes today. So I didn't share the notes. Let me see. Or Enrique, you can share the notes and then select Jupyter, please. Okay.
Just a second.
It's all yours.
Thank you, Carlos, for the introduction. So I'm going to paste the notes in the chat for whomever is interested in following. And then, so here we have in the notebooks, we have Langchain intro. So this will be the notebook that we're going to be working with today. And to do it, we're going to use Google Cloud. So the purpose of this notebook is that I'm going to give you a walkthrough what are the main features of Langchain, and how you can use it to to piece together an AI application whose backbone is an LLM. So bear with me for a few minutes. The first step is that you will need to install your dependencies. And since Langchain provides a facade on top of multiple components, you will usually need to install what's the core package, which is Langchain. And depending on what else you need to do, for example, say that you want to interface with OpenAI, or you want to use some of the community libraries or read the PDFs, you'll need to install those dependencies. As we'll see, you can ingest multiple types of files, like Word files or PowerPoint, slide decks, and so forth. Usually there are different Python packages that have already been created. Langchain provides an easy interface on top of those. But the bare minimum that you need to install is Langchain, and most of the time the OpenAI sub-package, because even though we're not going to be using OpenAI directly, most of the interface with LLMs uses the OpenAI API protocol. So as part of that, the first thing that we need to do is that we need to fetch what is an API key. So if you have an account with OpenAI, you can generate it. In this case, for today, we're going to be using Cyber's LLMs, which are compliant with the OpenAI API. And I have a private key for purposes of the demo. So usually you read that from the environment. Since we're here on a collab notebook, we are using Google's way to read the secrets. But the important part is that you need an API key and you need an endpoint. The endpoint is the server. And as I was mentioning, we're using Cyber's implementation. This happens to be that endpoint. If you want to replicate this on your own, reach out to us on the Data Lab Slack, and we can manage to give you an API key for testing purposes. So once we have cleared out those dependencies, the first thing that we have to do is that we need to create a chat object. It's going to be the basics of the interaction with the LLMs. And we're going to use it it's going to be the anchor or the cornerstone to create LSL expressions. LSL stands for Langchain something language, but it's just a way of creating pipelines in a declarative fashion. So we are going to make use of the OpenAI chat OpenAI implementation. So we need to import it, and we need to specify a specific model name. So here for today, we're going to use Mistral, which is an open source LLM. We have it hosted. So since this is not standard from OpenAI, instead it's hosted by ourselves, we need to point to the endpoint that is defined in the previous cell. So once we create that instance, then we can invoke the LLM. So in previous sessions, we saw how we could do this with, say, Llama. But if we were doing it with Langchain, the standard way to call a chain or a pipeline or a chat object is the invoke method. So if we are using an LLM, we're going to call it model because it's a large language model. But we can pass directly what is the question. So I usually like to start by doing a test call of the method to make sure that it works, because sometimes I made a mistake with the API key, or I set the environment incorrectly, or I forgot to do it. So this is a good way to spot errors. And here I just ask Mistral, hello, how are you? And I got this A message back from it. We'll see the details a little bit further, but the response is, hello, I am a model of an AI assistant, and I'm designed to help answer questions, provide information, and assist with various tasks. How can I help you today? As usual, when we're doing inference with LLMs, there's a ton of metadata. So you usually don't have to care about this unless you're keeping track of stuff, such as example, how many tokens did we generate? How many tokens were part of the prompt, what is the latency, etc. This object is called a message because chat applications are built upon the message history paradigm. And this paradigm has three types of messages: the system, the human, and the AI messages. There are basically rounds in the conversation, but they have several differences. AI and human message is, like as its name implies, or sometimes you'll see in other frameworks that instead of AI is assistant, but it means that this was something typed by the user, who is a human, and the AI is a response that comes out of the LLM. The third type, the system message, is optional, but when it's present, it's usually used to define what's the persona of the LLM. And this is useful when you want to establish the role or define the task that is going to be carried out during the conversation. So say that we want the LM to speak as if it was a university professor. You state in the system, you are a professor at the university and you're giving a lecture in front of a group of graduate students. Or if you're a news reporter, you stated like you are a journalist and you are writing an article about something. So that is going to condition the LLM itself. You can do it with the AI messages, but it's usually excuse me, useful to use the system one because the way these LLMs are trained is by paying attention to the system message for that purpose. So besides that, we usually have to put together the history of the conversation, and the history is nothing more than a list or an array of messages that are alternating. So first we have the system message is going to be the only one, and we start with a human message by opening up the conversation. So to do this, we are going to import the human message and the system message class from the Langchain core package, and we're going to define a history list, which is messages. And in this example, we're conditioning the LM to tell it that it is a software developer that is expert in the use of LM and Langchain. It is going to help us answer questions using didactic examples. So we're setting the tone of the conversation, and my opening question is, what is Mistral and why would I need to use it? So once we put together this list, we can invoke the model itself, which is the LLM. Previously in the prior cell, I passed directly a string. When that is so, it is considered to be an individual human message. But when we want to keep track of the memory of the whole conversation with the context, we need to pass the whole list of messages, the history. So once we pass that, we're going to get the response, which is going to be an AA message. And it's up to us to append it to the history. So that is why here, once we get the result, the response, we append it to the history. But we are also going to look at the content. We don't care too much about the metadata. So what is Mistral and why would I need to use it? Okay, so Mistral is an open source workflow system developed by Cloudbees. This is not true, but sort of makes sense. Yes, so this is an example of hallucination, but you can see how it is coherent. So you can see that it generates a verbose response because I asked it to give us a concrete and didactic example. So here, let's see how the history changed. We started by asking about Mistral. So we had the system message, the human message, and the A message. So I want to give a follow-up question. Based on the context that we saw before, I wanted to generate a Python script that calls the aforementioned LLM. And this is going to be interesting because initially the LLM thought that Mistral was an orchestrating framework. So let's see what happens here. We're in uncharted territory, so let's have some fun. Okay, so it says that it's going to use Hugging Face transformers to provide a convenient way to work with pre-trained models. And just by glancing at this, I can tell you that this is mostly correct. So this is the way how you could write Python with Hugging Face in order to call an LLM locally, not remotely through a client like Langchain. The only inaccuracy is that it is referring to T5 instead of Mistral. T5 is another LLM. So you can consider this equivalent. Those are the basics. So when you use Langchain, you have the abstractions for the messages, the message history, and the client to the conversation. But you can see how this can become cumbersome. Because what if you want to repeat the same thing? So let's step into the building and application territory here. I want to use an LLM to create a document summarization application. So I want to repeat it. So say that I am a teaching system grading essays, and I have a way to read the text out of those. So I don't want to create a different history of conversations each time. Instead, I want to create a template of the same task. So here's one of the main features of Langchain. It provides prompt templates. Concretely, probably the most important one is the chat prompt template. So in the chat prompt template, we can define a template for the whole history of a conversation. Here, we set fixed what is the system message, and it summarizes the document that is provided into a succinct statement with at most 3 sentences. And then the input or the message of the user is the document itself. So the user is not providing the instruction because the instruction was already defined on the system message. So that way, if I call it with a different document, it doesn't really matter. It'll use the template to fill in the gaps. So you can see here how in the user message, we have this expression, which is text surrounded by curly brackets. This is a variable inside of the template. So if you've used other templating language, you might be familiar with it. But if not, this basically means that I'm going to give you a field called text with some contents, and then those contents are going to be substituted into this field of the template. And for this application, I took the Bill of Rights and the US Constitution, and I want to get a summary out of it. So we took the document and we invoked the template. We fill it with the Constitution. So we're specifying that this variable that contains the Constitution goes into the text field. Once we have the prompt, the concrete prompt out of the template, then we pass it to the model itself. So we invoke it with the prompt. And what we're going to see here is how does the prompt looks, and then we're going to see the response out of it. So first, we have the system message. Then we have the human message. So notice here how text was substituted by the actual variable that we define here, document. Then, since the task was to give us a summary, the summary is this. The US Constitution grants Congress the power to enact taxes, regulate commerce, establish uniform rule of naturalization, coin money, etc., etc. So I could say that this is an accurate, I don't know if it's complete, but it's an accurate representation or summarized representation of what we saw before. But you might, if you're eager, you might see some inconvenience here. We had to do 2 steps here. So first we need to invoke the prompt template, and then we need to invoke the model with the results of that. So this is redundant, and this smells as anti-pattern. That is where LSL comes in. If we had to call invoke multiple times, we can streamline it by chaining those invoke calls together. And that is what the concept of chain for Langchain comes in. You might have seen it before in other frameworks or other libraries as a pipeline. But here, the chain first puts together or binds together the prompt template with the model. So what this means is that we're going to take the output of the prompt template and pass it as an input to the model. If you've used Linux or any Unix-like system before, you have seen this as pipes. It's the same abstraction. But by doing this, we have a chain object that we can invoke it. So the input of the chain is going to be the input to the first element of that chain itself. And then those outputs are going to propagate. And the output of the chain is going to be the output of the last component of that specific object. So here we're going to do exactly the same, but you can see how we reduce the number of calls just by 1. But like if the chain becomes longer, you can start to see the value. So it is the same output. So far so good. So I want you to look at this line. So when you see the response, when we inspect what are the contents, we need to inspect the content field. This is because the last message is an AI message. But when you're building an application, you may not care about the metadata itself. You just want the string out of it. So Langchain contains some utilities called output parsers. These output parsers takes objects and transforms AI messages and transform the contents into specific format. The most basic one is the string output parser, but there are multiple others. So you could have a JSON output and you want to build a Python dictionary out of it, or you may have an HTTP response, or you might want to build an HTTP response out of the contents and so forth. There are utilities for that. So let's take an example again. Take a look at an example again. We are importing the string output parser from the core package. We create an instance out of it and we append it to the chain. So see here how the chain starts to become longer. Now we have 3 components. When we call it and we want to see the response, notice here how response does not contain a content field. So let me scroll up a little bit here. So here we need to access the content field of the response object. Here we're looking at the response object itself because it is a string, and that is warranted because we're calling the string parser. Basically, this one is just selecting the contents of the content field, but we'll see an example of how can we make use of more or a smarter version of this. So again, we get that summary of the Constitution, and here, like you can see how we are starting to leverage Langchain constructs to build an application with multiple steps in a declarative way. So we define what are the steps, the data flow from the beginning. We specify what are the inputs. So the inputs should be just an object or a Python dictionary that has a field called text with whatever we want to pass as the input. And then we can collect the results without having to do any extra steps, as if it was done imperatively or in low level way. So the takeaway of LCell is that the pipe operator connects together individual components, and we can leverage the syntax to define pipelines or chains, which chains are basically pipelines of components that orchestrate that data flow. So at each step, we might be doing some pre-processing, we might be calling an LLM, we might be calling a vector database to retrieve results, we might be calling a bespoke utility to process those results. Then we want to do some post-processing. Perhaps we want to take a JSON output and build a Python dictionary of it. As long as we have those individual components pieced together, we can put it together as a pipeline or a chain. So I've been saying JSON a lot here. So I wanna give you one example of how this can become really powerful really quickly. So one application. So let's build a toy AI application. I want you to take a look at this PDF file. So this PDF file contains a fake invoice, but you can see that the format is here. So we have what is the business, what is the address of the buyer, and some data, the header of the invoice, table with items, and each item contains units price amount, what is the total. We have some metadata, and we have extra stuff. So something that comes up fairly often when you're building transactional systems is that you want to have this representation as a JSON data structure. So that JSON data structure, you can render it as a PDF. That's fairly simple. That's been done for decades before, but it's not as trivial to go the other way around, because reading a PDF it's not easy. I mean, yes, it's easy to read it, but read it well, it's not easy because it has a lot of noise. So you need to deal with that. One way to deal with it is by using LLMs, because the LLMs have proven to be very useful to extract information without having to hard code the patterns. They're able to figure it out based on their training, their extensive training. So one of the components, one of the multiple features of Langchain is that it has wrappers for multiple loaders. And one of those is the PyPDF loader. PyPDF is a Python PDF reading library, as its name implies. But we wanted to be able to connect it together in those pipelines of objects. So we are going to take the wraparound PyPDF loader, and we're going to read that sample invoice, which is the file that I was showing you here. I got it from the internet, and it seems generic. So even though it's in German, I think that it's easy to understand the point. And we're going to build a function that uses that PyPDF loader to get the text out of it. So in this function, we receive a string that contains the path. We instantiate that PyPDF loader class, and we load it. So PDF have multiple pages. We're going to iterate through each of the pages in that PDF, and we're going to get the text contents. So since we may have multiple contents pages, we're going to concatenate the contents of each page with a new line character. That way we will have a single string that contains the text in all of the pages. So let's run it with that sample invoice PDF. And this is the result. As I was mentioning, it is like, yes, it is relatively trivial to load the text out of a PDF, but to load it cleanly, it's not. So how do I know where does the table start? How do I know which of the lines correspond to a row and which of the lines correspond to the same column? So this is all serialized in a sense. We want to give it structure into a JSON object that can represent those tables. How do I know if this is the business, the seller business? How do we know that Mr. John Doe is the buyer? How do we make sense of multiple elements in here. Like, what is this? Is this a line item? Is this some footer? So we don't know. So it is not trivial. So we might have a sense, but coding something that is not brittle is extremely hard because each business is going to have its own format. So at least we have the means to extract the text. But you might see here that we just used a user-defined function. How can we connect this into a pipeline, a chain expression? So here we start to step into the a little bit intermediate knowledge of Langchain. Any function that we do, we can make it a component of a chain using the runnable lambda. Runnable lambda, so the name might not make sense, but runnable means in Langchain's lingo, any element that can be chained together is runnable. And lambda is just a way to refer to functions, because it could be a lambda expression or it could be a function itself. So if we grab a user-defined function on a runnable lambda, then we'll have the object that has the invoke method. And this is what we want to do. So here, just let me scroll up a little bit more. You can see how if we want to read this PDF, we just call the function as usual on traditional Python programming or procedural programming. We print the results. But once we wrap it on a runnable lambda, this PDF reader object contains the invoke method that in turn runs the read PDF user-defined function. So we're going to do it here, and we're going to see that we get the exact same result. So why is this important? It is important because first, you see that the return type is a Python dictionary that has the text field, and we're going to find a chain. This chain processes the contents of the PDF. So the first element is the PDF reader, but now we want to define the app quote unquote using the LLM. So we're going to use again the chat prompt template using the same pattern as I showed above. And we're going to condition the LLM through system message. So that system message reads, you are going to read the contents of an invoice in PDF format. This is important. We need to be specific about what we want the LLM to do. By doing this, it might know that noisy text is coming its way. Return a JSON object that contains the data of the invoice using the fields and values from the text below. So we're setting the scene to do it. And the first user message is going to be the contents of that PDF. So the cherry on the top of the cake is that we don't want to read the text. We want to take that JSON object and we want to load it as a Python dictionary. So for that, there is the JSON output parser. This parser is going to take the string. As long as it's a well-formed JSON string, it's going to parse it and it's going to build that Python dictionary with those fields and those values. So finally, we'll put together the whole pipeline. The first element is the PDF reader. So then we pass a path to that PDF reader. This runnable or component is going to open that PDF file and read the text out of it. It's going to format it to concatenate all the pages together. Then it's going to pass it to the prompt template. The prompt template has a field called text. So the output of the PDF reader goes into the text field of the prompt template. And the result of the prompt template is a prompt that has those contents substituted into the user message. Then that goes into the LLM itself that uses the message history to figure out what it has to do. On the system message, we specify, this comes from a PDF file, and we want the JSON string with these specific characteristics. So ideally, we cannot 100% control this, but if it's a good, well-trained model and we're specific enough on our prompt, it'll give you a well-formed JSON output string. And then we're going to pass it to the JSON output parser. We're just instantiating it here below the Python dictionary. So in the end, this object chain is our AI-powered application that uses an LLM as its backbone. So let's invoke it using that PDF and print it. It's going to take a little bit because it's, first of all, it's a longer string. So you know that the LLMs take square time in the number of tokens. So the longer it is, the proportionally square time it takes to run. But it also has to, like, when you ask something complex, it usually takes a little bit longer. So let's see. Okay, so this is a good lesson. First, I want to read what is the exception. So we got an error here. This is an invalid JSON output. And why is it? So this prints what is the actual output. As you can see, the first line has this, and this is a markdown component. This is not a JSON component. That is specifying that whatever comes in its way is a JSON object. But ideally we wouldn't want this. So you may need to code around this. This is relatively easy to fix, but for the sake of this example, let's look at the contents. So here we have the biller field, and this is the name of the company. It has an address. So this is CPB software, and street is I am branch 3. I don't know if that's a pun, but let's go to the file. CPB software, yes. I am branch 3, yes. So we have a phone number, an email address, and a website. Let's go and see. So on the address field, it's just giving us the actual street address, which is good. And it's broken down by street, city, postal code, which is the zip code, and the country. Then we have the recipient name, mustard count AG. Let's go here. Yes. And the address is Mustard Street or Mustard STR 23. I think this is fake, but I don't know. I don't speak German. So my apologies if this is a legit word. The contact is Mr. Gendo. This is apparently a phone number, probably well formatted. It has invoice details. It has date. This must be March 1st. And it has a service description, VAT number, must be, I know, the equivalent of the social security for a company in Germany. Terms of payment. So if you see, it sort of makes sense. Like it looks accurate. So one lesson here, as I was mentioning, is that even though it looks okay or it looks correct, you need to inspect it because there might be some inaccuracies on the field. But let's see. So invoice items is a JSON array that has multiple JSON objects. It has the name of the item, the amount, account, and some information about the transaction. Let's see here, continue the pattern for the rest of the items. So this is something lazy out of the LM. This shouldn't tell you this, it should do it. So when you're developing an AI application, either with Langchain or not, you need to take a look into this. And you need to specify or to be more specific on the prompt let's see if I can quickly fix it. So strictly JSON without any markdown elements. Be sure to include all the information in the invoice. Then if it seems repetitive, let's see if this works. Oh, yes, my bad. Don't bail me, Mistral. There you go. Okay. So there was no error this time around. JSON output parser worked. So I'm just going to scroll down a little bit more. So we still do not see, well, we now do not see any comment that says repeat the pattern. I know if this includes everything. But again, like this is an iterative process. You need to look at it and make sure that it actually works. And finally, I want to print what is the type of invoice object, which is what we're returning here, invoice. And you can see that this is a dict, that is the Python dictionary data type. If this was a JSON string, it could have been a string object. So this is the type of stuff that you can code with Langchain. And that is the end of today's demonstration. But I want you to, if you're interested on this, you must know that with Langchain, you have more advanced constructs. For example, you can create parallel branches on the pipeline, and then you can merge them together. You can have conditional if-else statements that direct the flow of information, and it can actually become quite complex. And one of the downsides of Langchain is that when that topology of the pipeline starts to become complex, meaning that it deviates from that linear chain pattern, it becomes cumbersome to maintain pretty quickly. But like this is what we have today. There are alternatives, like Carlos once mentioning, Llama Index is one of those, or you can code it yourself. Like you don't really need Langchain, but you're giving up this ease of interfacing with LLMs and adjacent components for more fine-grained control. So it's up to you, depending on what's your need. If you want to incur into technical depth by becoming a pretty advanced Langchain user, or if you want to spend more development time and do everything more by hood. So yeah, that is it. So if you have any questions, please feel free to ask. We still have a few minutes. All right, so I guess that's no question. So again, like if you want to replicate this.
I have one question. I just wonder if the notion of a prompt engineer that we see in just in the general news, is that really referring to somebody that knows how to manipulate these prompts that you showed us today?
Yes. So that's a great question. As you saw on the last cell, LLMs tend to be stubborn, so you need to know your way around crafting those prompts. And that'll depend on what is the actual model that you're using, because some are going to follow your instructions more directly. And that is the whole point of a prompt engineer. So this doesn't require intricate knowledge of how the LLMs work from the inside, but you have to have the notions of how do they behave. And there are several well practices already laid out for us that you can find on the deeplearning.ai course or on the internet. But as a general rule of thumb, the more verbose and the more specific you are with your prompts, the better results you're going to have. Of course, like if you want to be very, very specific with a prompt, it's going to require more effort from you. You can also get better results when you include examples. That is called in-context learning. And it really depends on your data, on the model, and on the task that you're trying to achieve.
Thank you.
So, of course, you also ask about, oh no, this is Alan Jackson. You seem to be using Verdi. Can you explain it? Yes, indeed, I am using Verdi. So I'm going to scroll all the way up to the first cell. And Verdi is the brand name of the hosted LLMs that we have on DSI, DSI/Cybers. And the idea behind this is that even though we are using the chat OpenAI class, it doesn't have to be an OpenAI model, because we don't want to pay for it if we, as an institution, have that model already instrumented for us. So in the end, the way that you, as an application developer, the way you call an LLM has already standardized, and it has the field has relied upon.
So it's a server that you're running on Cybers. Is that it?
Yes. We have a couple servers with multiple dedicated GPUs provisioned exclusively for LLMs. So that is why we can do this, but we support concurrent users. It's like pretty big stuff server that contains many GPUs.
Is it generally available as a tool, or is the Verdi part of the HCI, the high computing interface?
It is. So I could say that it's in between. It is generally available as a tool, but it's not open. So you will need to reach out to NeurApp or somebody of us, and we can issue API keys for you. So that will probably require you to speak with someone to see what you want to do, and then we can provide some guidance on how to use it.
Okay, yeah, because I got it to step 2, and I put my own API key in for OpenAI, and
Yeah,
I just got stuck. Yeah. All right.
yeah. So if you want to try it, you can just comment out the API endpoint here, and comment out this. Oh. So don't specify the API endpoint. And this is going to work. It's going to work with, well, you'll need to do something here like GPT 4.0.
Right.
It's going to work with OpenAI, but
Thank you.
You're going to be paying for the API calls.
Yeah, it goes with the territory. Thank you very much, Enrique.
Of course. So is Chat OpenAI open source? So Langchain is open source. And if you mean is the source code of this class open source? Yes. The OpenAI API is, I don't know if it's open source, but everybody uses it. Olama uses it, Langchain uses it, Hugging Face uses it, OpenAI uses it. And I bet that probably Phi and Gemini probably have their own compliant API endpoints. So I could say that yes, it's open. All right, so hope that answered your question. Yes. So by chat OpenAI, we can use any model that supports it. Yes, you do. This is not the only one. For example, if you are say that you want to use what is this model? Carlos, do you remember the French model from Anthropic?
Yeah, Claude.
Yeah. So there's a specific one for Claude. So you just need to import it. In our case, the models that we have on Cyberse/Verde are Mistral and Llama 3.1. Depending on the provider, that's going to change.
All the models which are open source are hosted in Hugging Face, so you can use any model, basically.
Yeah. So you can run it on your laptop. So I think that one session ago, it was the Ollama session. So if you download Ollama and you run it either on the HPC, or if you have, say, a MacBook Pro, you can run it on your MacBook. And Ollama also uses the chat OpenAI protocol, but there's also the chat Ollama class that you can use yourself. And all of these are drop-in replacements, so the model component of the chains can just be changed or swapped out. It'll work. Your mileage may vary because depending on the model, you'll get different quality of results.
Yeah. And Enrique, while we are here, we would like to announce that we will start a new workshop on Fridays at 3 p.m. Where Enrique and Mitun will be talking about, it will be a makerspace AI. So we will be showing how to use large language models and everything related with that. So it's going to be virtual, and you will find the same Zoom link as this workshop and every other workshop from the Data Lab. So please join us on next Friday to see all the details how to work with large language models. But it's going to be hands-on, yeah?
Yes, it's going to be hands-on. So we are not dealing with LangGraph just yet, but the topic list is quite open. The idea behind it is that either Mithun or myself are gonna sit and then just start coding something related to the research that we do. It's going to be a little bit more advanced than these workshops. For example, tomorrow I'm going to sit and I'm going to train ResNet using ImageNet on the HPC using 2 nodes. That means 2 GPUs on separate computers. The idea is how to make it work. And the idea of this workshop is that if you are a faculty or a graduate student that you want to learn how to use machine learning tools with the computing infrastructure that we have, we're going to sit down and try to run in 1 hour. We might succeed, we might not, but it's meant to be a conversation of how we would go about it. And great, so thank you for those suggestions. Agentic LLMs could be an interesting topic for one of the sessions. Okay. So we will start adding the topics a week or 2 in advance on the website.
Okay. We will transition to the next talk. Thank you for connecting. So